WhatsApp group. Okay, today is this replacement class number 2, the second replacement class. I hope I will I will today I will cover topic 3, financial mathematics. That is about annuity. Yesterday I finished to explain about the simple interest and compound interest. Okay, before I continue this lecture today, okay, as usual, if you have please mute your microphone, because I will record this class just for and the recording will be used by the student for their reference. Okay, if you have any question, you can ask me anytime. Just turn on your mic and ask your question clearly. And then please let me know if my audio or my visual are not clear. Uh, this file, this topic, the file for this topic, you can download as usual from UKM for topic 3, financial mathematics. There is Annuity. Okay, for today, what is annuity? Generally, annuity is we can define annuity as is a series of payment that made at the fixed period over a period of time. That's the definition of annuity. What is annuity? And then the annuity payment basically are not necessarily the same on each period, but for this class, for the purpose of this class, we assume that the amount of the annuity are the same and fixed throughout the period of the study. An example of an annuity is amount of money that you save at the end of each month. Let's say end of each month, you deposit your money in a bank with a fixed amount, let's say 100, 200, and so forth. That's one type of the annuity. And also the repayment of the housing loan or vehicle loan or car loan. In Malaysia, we have a personal loan, a housing loan, car loan. And every month, if you borrow some money from banks to buy house and car and so on, you need to pay back to the bank every month, end of month. Okay, that amount we call it as annuity, and there is annuity. And in general, annuity can be divided into two type of. There are two type of annuity, and namely the ordinary annuity and annuity due. Okay, what is ordinary annuity? Ordinary annuity ataupun annuity biasa. Ordinary annuity involve a series of payment that made at the end of the period, end of month. Any amount that we pay at the end of month, such as for our loan and so on, we call it as the ordinary annuity or annuity biasa. And also, if you work every end of month, the workers will receive we get their paid but from their employer. That amount we know as income or wages. That's also one of the ordinary annuity. While the annuity due, okay, annuity due, or it's not mature annuity, annuity due. In Bahasa Melayu, we call it as annuity matang. Annuity due is a series of payment that made at the beginning of the period. For example, at the beginning of month, year, quarterly, and so on. That we call it as a annuity due. For example, we can for example, the payment of the rental payment. When you rent a house, you need to pay the fee or the rental fee. Normally, the rental must be made. The rental of the house must be paid at the beginning of the month. But in this chapter, okay, in this chapter, for this class, I will focus on ordinary annuity only. Okay, in this topic, in this annuity, in order to explain the annuity, the concept of ordinary annuity, uh, we will again will apply the concept of simple interest and compound interest. Basically, there are still simple interest or compound interest that we have learned yesterday, but in this case, we have more than one compound interest. There is the fixed amount that you have to pay or you will receive is subject to the whether there is a loan or investment and so on. So in this class, basically there is a link. Ada hubungan. There is a link between the compound interest and annuity. Okay. For the first part of this topic, section 3.2, I will explain about the future value of ordinary annuity. Uh, 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 in the previous topic, I explained to you about I explained about the future value of money. This is still by using the same concept, but now I will explain to you the about the future value of ordinary annuity. Okay, what is the future value of the ordinary annuity? Okay. Uh, if you look to the section 3.2, the future value of ordinary annuity refer to the summation of all future value. In other words, we have more than one future value where payments are made at the end of the term. That's the future value of annuity. That involve the combination of or summation of all future value of money, all future value of the compound interest. That means that the future value of money at the end of each period should be calculated one by one. That's the idea. The future value of money. The future value of money must be calculated one by one and sum up all together to obtain the future value of annuity. To obtain the future value of annuity. This is a future value of annuity again. That's the future value. That again, this definition show that there is the there is a close relationship between the uh, future value of annuity and future value future value of money. In other words, we can say that the future value when we're talking about the future value of annuity, we have more than one future value of money. We need to calculate the future value of money one by one and sum all together to obtain the summation of future value of money is future value of annuity. Uh, uh, perjumlahan uh, nilai nilai wang pada masa depan setiap satu akan menghasilkan future value of annuity. Nilai hadapan bagi annuity biasa. Okay, for example, let's say, okay, I will explain example 3.1. Please refer to page 1 and page 2. There is a graph, figure 3.1. Figure 3.1 will show you the how to explain the future value of annuity by uh, 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 figure 3.1 will help you, will explain, which show, this figure will show how future value of money will use to explain uh, the future value of annuity. That's there is as I said earlier, there is a relationship between future value of money and future value of annuity. Okay, let's assume that uh, okay, based on example 3.1, let's assume that let's assume, okay, where's my, okay, let's assume, suppose okay, let's assume that you have 100 ringgit. Uh, you wish to save, to deposit your money. Uh, let's say at the end of month, at the end of quarter. Okay, at the end of each quarter, uh, you are planning to deposit your money. You are planning to save 100 ringgit in a bank account at the end of each quarter, at the end of March, end of June, end of September, and end of December. Let's say that's the assumption that, and then for 2 years, you will keep save your money at the end of quarters for 2 years, from year one until year three, maybe from 2025, 2026, and 2027. Let's say if you start to save your money this year, every quarter, end of March, end of June, September, and December, you save your money for 3 years. And then the saving account offer a saving interest rate of 6% per annum, compounded quarterly. Compounded, compounded quarterly. Okay, that's the data, based on, for example, 3.1. You have 100 ringgit today. We know this a P, your principal, and for each quarter, and the interest rate is 0.06, compounded quarterly. So M equals 4. This is still the same based on the previous chapter. If the interest rate is compounded quarterly, in other words, the interest rate is compounded 4 times per year. Every year there is every year the interest rate is calculated is calculated 4 times and at end of March, June, September, and December, 4 times. That's why M equal to 4. Now, but please remember that in this case, we assume that every quarter you will save your money. So let's say now we focus first on the first 100. The first 100. Let's say the first 100. Okay, how to do? Okay, let's say okay, before I explain this graph, let's say okay, for example 3.1. Okay, okay, let's say you have 1,000. Sorry, 100 ringgit. You wish to you wish to deposit this amount of money at the end of each quarter. End of quarter, 4 times per year, quarterly. End of quarter, quarterly. M equal 4. Okay. Let's say we start at 2025. 2025. We have 2025 first quarter 2025. Let's see how to write 2025 quarter one. Let's say 2025 quarter one. Quarter one include January, February, and March. That's it. January, February, and March. And and then this activity is just for 2 years. Just for 3 years. And then we have at the end of 2025, 2026, 2027, quarter four. Now, this process start from first quarter of 2025 until end quarter of 2027, quarter four of 2027. That include October. October. The October, November, December, right? October, November, December. Okay. Okay, now we are talking about the first 100. Let's say end of quarter end of first quarter, end of quarter one of 2025. You deposit here 1,000. Sorry, 100. You deposit 100 end of March or end of end of quarter one is equal to end of March. You deposit 100. This money, this amount of money will be kept in the bank until, okay, I got here, until end of quarter 2027, because this deposit is just for 3 years. That's why 2025, 2026, and 2027. Now we want so what happened to this 100, to this first 100? If you save this 100 at the end of quarter one, and then the money, we assume that will be continue in the bank from this from quarter one 2025 until quarter four and quarter of 2027. So in total, we have 12 quarter. 2025, we have quarter one, quarter two, quarter three, quarter four. 2023 also we have quarter one, quarter two, quarter three, quarter four. Also 2027 we have quarter one, quarter two, quarter three, and quarter four. So in total they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They are 12 quarters. 12 quarters in total, because this is for 2 years. Okay, now we want to what happened to the first 100? Let's say you keep this money from first quarter of 2025 until the end quarter of 2027. First quarter, since there is ordinary annuity, the money you deposit the money. Let's say the money is deposited in the bank at the end of March. So we are now we want to calculate the future value of money, the future value of the 100 at after 2 years, at the end of fourth quarter of 2027. So what is the formula for the future value? S equals P 1 plus R over M to the power of n. Okay, we will apply this formula. So this future value, the future value of the first 100, 1 plus R. What is R? R is 0.08. I think 0.08. What is R? Okay, R is a 0.08. The interest rate, the nominal interest rate is 0.08, but compounded quarterly. The power divide by 4. So what is n? Again, n is m times t. We know that m is 4. Okay, m is 4. And what is t? In this case, t equal 12. T equal 3. Normally, t equal 3. There is equal 12 quarter. Okay, for 40 years. But for this case, n should not 12. So 12 is also equal to the number that interest rate is calculated for the 3 years. But in this case, since the money is deposited in the bank at the end of quarter one. Normally, when we said that the interest rate is compounded quarterly, normally bank will calculate the interest rate at the end of first quarter, at the end of every quarter. So in this case, at the end of quarter one, bank will calculate the interest rate. But at that time, you have just deposited the money. So the first 100 will not receive the first dividend, will not receive the interest rate, will not receive return. It's not qualified for return. In other words, the first 100 is not qualified for interest rate will not qualify the interest rate that calculated in the first quarter of 2025. Why? Because the first 100 is deposited at the end of quarter one. In order to qualify, in order to receive the full, in order to receive the full the interest rate for the first quarter, the first 100 should be deposit at the early at the 1st January or early of January. But in this example, we assume that there is the ordinary annuity. Ordinary annuity mean reflect the ordinary in annuity refer to the financial activity that occur at the end of the period. So it's seen there is a quarterly. Uh, when you deposit the first 100 by using the ordinary annuity concept, the 100 is assumed to be deposited in a bank at the end of Q1, at the end of quarter 1. So, therefore, the first 100 will not receive any dividend for the first quarter of 2025. This amount of money will receive the interest, will receive the interest rate starting from quarter 2, 3, and until quarter 4. That's why the M is not 12. The M is 11 for the first for the first 100. That's why that is how to calculate the future value of money. Okay, that if you calculate this number, that's why you need a calculator. Then 100 times 1 plus 0 0.08 divided by 4 to the power of 11, not 12, to the power of kuasa 11. 124. For example, this is 124.34 cent. Okay, that's for the first 100. The first 100. So at the second quarter, at the quarter 2 of 2025, end of June, you deposit. We assume we deposit another 1,000 in a bank, and then now we need to calculate the future value of annuity, future value of money for the second 100. So there is again 100. 1 plus 0.08 divided by 4 to the power of, okay, to the power of what? Okay, now you need to understand it. You must understand this concept. The second 100 is deposited in a bank at the end of quarter 2. So the second 100 will not qualify, will not receive dividend for Q1 and Q2, for quarter 1 and quarter 2. The second 100 only receive a dividend starting from the quarter 3 until quarter 4 of 2027. So we have 10th quarter here that where we have 10th quarter that where the second 100 where we will receive the dividend from the 1,000 ringgit that we deposit at on quarter 2 of 2025. So now this is the power of 10, not 11. It's 10. You can calculate it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This process continue for each quarter. Let's say this third 100, 1,000, 1 plus 0.08 divided by 4 to the power of 9, and until the last 100. In this case, the last 100 will not receive any dividend because the last 100 this deposit at the end of quarter 4, that is to the power of 0. That the process is continue, as you can see in my figure 3.1. I'll show you. Okay, that is the how annuity works. How annuity works for the first 100, second 100, third 100 until the last 100. Okay, this is actually 1 plus 0.02 to the power of 0. 0.02 is this equal to 0.08 divided by 4. That's why we have 0.02. Okay. Now, in this case, we have 10 future value of money. Uh, 10 future value of we have not 10, it's 12 future value of 12 future value of money. In other words, to find annuity, to calculate annuity, we need to uh, we need to sum all the future value of money. In the case we have 12 future value of money, we need to find the future value of for every 100 ringgit that deposit in a bank. So when you manually, if you use this concept as a manual, whether which is uh, the future value of any money is calculated individually, and then you need to sum all the future value, you will get the answer is 1,341 and 21 cent. Okay, that is a long process. For exercise, I encourage you to calculate this value one by one and make sure you get this number 1341.21. Okay, in other words, if you deposit your money every quarters for 3 years, and the saving rate offer you the saving account offer you 8% per annum compounded quarterly. At the end of year 3, at the end of quarter 4 of year 3, your money will go to 1,341 and 21 cents. And that's how uh, uh, that is all about the future value of annuity. So in other words, the future value of annuity normally we can refer it as the combination of future value of money. The total of future value of money, total of the related total future value of money equal to the future value of annuity. Okay, that's the about the annuity. Okay, in short, uh, in mathematics, we can simplify this process. Actually, no need to calculate this one by one. I just explain it in detail, just to introduce about to introduce to you the concept of the annuity. But in general, we can conclude that this calculation can be simplified can be simplified by using this formula 3.1. That is the formula for ordinary annuity, where S is a future value of ordinary annuity, R is a annuity payment per period, and number of payment I interest rate per period R over M. M equal to number of compound in a year. T is a number of year or times per year. Okay, that is this formula is very important and then that is the formula that used by the bank to calculate the future value of anything. Okay, for example, let's say we have based on this case, 100 deposit in the bank for each quarter. We have 1 plus I 0.08 divided by 4, m equal to 4, to the power of what? N. Okay, in this case, n equal to mt. M equal to nt, because now we are using formula that is the power of 2 minus 1 divided by 0.08 over 4. That is R over M. Okay, I. And then you just calculate this. The answer is, you will get the same answer, 1,341.31. You will get the same answer. I hope you can try to calculate this formula. Please use your scientific calculator. Make sure you get this number. That's what we call it as a present value of future value of anything. Future value of anything. Okay. Any questions so far?
No questions, doctor.
Okay, please look look into example 3.2. Okay, suppose Abu deposit 200 ringgit every month for 20 years. Suppose Abu deposit 200 ringgit every month for 20 years. If the interest rate on saving is 3% per year, compounded monthly, what will be the amount of saving at the end of 20 years? Now, let's say, in other words, we assume that Abu deposit 20, yeah, how to, let's say, you deposit 200 ringgit every month. In the case, every month for 20 years. 20 years. 200 ringgit for 20 years, every month for 20 years. Every month. The interest rate, let's say the saving account offer the interest rate of 3%. 3% compounded monthly. So the question is, what is the amount of your saving at the end of 20? After 20 years, how much is your saving is? Okay, how to estimate this number? Okay, now we assume that every month Abu deposit 200 ringgit every month for 20 years. Every month for 20 years. So there is the amount of annuity. There's amount of annuity, because there is there is process. The same amount is the deposit in a bank. That's we call it as a annuity. Where at the end of where there is a fixed amount that deposit in a bank, or that include the series of payment. R equal to 200 is also called as a series of payment. Okay, for how many years? For 20 years. So T equal 20. 3% is the interest rate. R 3% interest rate is compounded monthly. So M equal 12. Compounded monthly, M equal 12. So we want to know after 20 years what happened to this investment, how much, what is the amount of the investment after 20 years. So in this case, since there is a series of payment, we must use the future value of annuity. So this is equal to 200. We have 1 plus 0.08 divided by M. M is 12. To the power of, okay, the interest rate is calculated 12 times per year. Monthly means that 12 times per year. So for 5 years, the number of the interest rate is calculated M times T. M is 4. M is 12. Sorry, M is 12. 12 times T. N equal to 12 times 20. 12 times 20. Now we have 240. In other words, the interest rate is calculated 240 times for 3 years. So -1 divided by the interest rate. We have R is interest rate per period. There is I 0.08 divided by 12. Okay, just complete the calculation. The answer is equal to 65,000. 65,000. 660.40. Okay, that's the answer. After 20 years, your saving will increase to 65,660. Okay, that's it. Now let's say we would like to from this amount, we want to know your total principal. Your total principal meaning that your total your money. This not include the interest. your total principal and total interest. Total interest that you receive from this from this transaction, from this deposit account. So we can calculate the total and the total interest. So what is the total principal? Total principal, uh, let's say this for 20 years, 200 per month for times 12 times uh times 20 years. Okay, this is equal 200 times 20, 240 months, because there is a 240 months in four in 20 years. So we have and then total number of months is 240. We just get the product of 200. 200 is the ringgit Malaysia. It's the value of the money that you deposit every month times 240. You can see your total money is 200 times 240. That's of 48,000. Your own money. The original the principal, because that money is belong to it's not include the interest. So the total principal for this case is 48,000. The total interest, okay, the total interest that equal to uh future value of annuity as minus principal, total principal. Total principal. So what is S? S is equal to 65,660.40 minus total principal 48,000. That's equal to just 65,660.4 minus 48,000. 70,000. 65,660.4 minus 48. 1, 2, 3. 76,660 and 40 cents. That is the total of interest that you receive when you from a bank, total of interest that you receive after 20 years. And then the future value of money, 65,660 and 40 cents, can be divided into two elements here: total principal and total interest. That's how to calculate the future value of money. In other words, if every month you save 200 ringgit for 20 years, for 20 years, with and then the interest rate is the interest rate is 3% per year. 3% per year. We have 0.03, 3% per year. 0. Sorry, there is not 0.08, 0.03. 0.03. Okay, the interest rate is 0.03 per annum per year, but compounded monthly, m equal to 12. So you will get the future value of your money is 65,660 and 40 cents. But we can divide this amount into total principal and total interest. The total principal is 48,000 and total interest is 70,160 and 40 cents. Okay, that's concept of the future value of annuity. Okay, the next one is about the present value of annuity. Before this, I explained about the future value of money, but now, future value of annuity. Now, future value of ordinary annuity. What is an ordinary annuity? Ordinary annuity refer to the payment. There is a series of payment that you made that the process, the series of payment is made at the end of each quarter. Now we want to what is a present value of annuity? Okay, the present value of annuity is the summation of all present value of uh present value of the present value annuity is summation of value of all present value for series of payment that to be made in the future. In other words, you are plan to pay some amount in the future. So we can calculate the future, the present value of the payment. In other words, it also represents the amount of money you need today to fund investment in the future. That's also another example for the annuity. In other words, we can represent this ordinary annuity, present value of annuity as a amount of money that you need today to fund investment in the future. In the future, for example, let's say, or in other words, you could also say how much money does it take today to finance or purchase of asset. Let's say you are planning to buy a house that the price of the house is, let's say, 500,000 or 5 million. Okay. Now in order to get the 50 500,000, how much money you need to save every month from today? That's why that's the concept of future present value of anything. Okay, for example, let's say in this case, let's say we assume you intend to purchase asset worth 3,000 in the future. And then the purchase of the asset involve a payment of 1,000. Let's say you need to pay 1,000 annually for 3 years. Okay, to achieve the objective, what is the objective? The objective is to purchase our asset. Purchase our asset include the asset, the price of the asset. In other words, you need to pay 3,000 ringgit in the future to buy the asset. This, let's say, assume that this process, you need to pay 1,000 annually for 3 years. So the question is, how much money does it take today? How much money you need today to finance or to purchase the asset? We assume that the interest rate is 5% per annum, compounded annually. The interest rate is 5%. The return is 5% per annum, compounded every month, calculated every month, compounded annually. So again, in this example, we need to find the future value, the present value of 1,000 ringgit that you need to pay in the future. That's the concept of annuity. Let's say this is for 2 years. We have year 1, year 2, year 3, and then you need to save your money at the end of year with the saving interest rate 5%. With the saving interest rate of 5% that compounded annually. So to find the present value, okay, again, we see this formula. We can apply the formula 2.9. The formula 2.9 is as described in chapter 2. Okay, there is the formula for future value of money. That is the future value of money. So in other words, okay, let's say look at this amount of money. Okay, look at this figure 3.2. How to what is future present value of money? How to describe present value of ordinary annuity? Let's say we have year 1. This is number of year. We have year 1. So at the end of year 1, year 2, and year 3, you need to pay 1,000. This is 100. This is 1,000. I think. Please add into your note another 0 because the example refer to the 1,000 ringgit that you need to pay the amount. So And then since there is a ordinary annuity, this is a ordinary annuity. We assume that the payment is made at the end of year one, end of year two, and end of year three. That's about the present value of the annuity. Okay, now we need to calculate the present value of the first 1,000, second 1,000, and third 1,000. 1,000 for every uh, for every for every for every year. Okay, for the first 100 that you will pay in the future at the end of year one. Let's say at the end of this year, at the end of this year, you need to pay uh 1,000 ringgit. So what is the present value of the 1,000 ringgit? If you plan to save your money in a bank, how much money do you need to save today in order to receive 1,000 at the end of year one, year two, and year three? In other words, we need to calculate the present value of the annuity. Okay. What is the present value? Formula the present value: P equal to S 1 plus R over M negative N. That is the basic formula. The future value of money. uh, if you refer to the formula 2.9. So for the first case, for the first 1,000, okay, for the first 1,000 in this case, we have P S is 1,000, R is 0. R is 0.05 compounded yearly. So M equal 1. For about how many years? For three, I think for 3 years. That's why the graph shows first year, second year, and third year. So now we need to calculate the future value, the present value of each 1,000 that we need to pay later. For the first 1,000, the present value is 925.28. The second 2,000, the present value is 907.00, and the third 1,000 is 600 863 and 84 cents. So now we have three present value. Each present value represent future value of 1,000 at a different year. So all these present value, the combination of this present value, if we calculate this number, we just plus, we get the summation of this number. As you can see in page 3, the summation of this the summation of individual present value will result in a present value, the total present value. It is total present value. The total is 2,723 and 25 cents. Okay, this total is also referred to the present value of annuity. In other words, the present value of annuity is a combination of present value of money that we need to calculate individually every cases. But in general, we also need to report the present value of ordinary annuity. That is the difference between the present value of money and present value of ordinary annuity. So, okay, this number, the present value of annuity, in detail, I've just shared with you what is the concept of present value of annuity. Okay, in detail, we need to calculate every one present value of annuity one by one. But there is a formula that will help us to calculate the present value easily. There is a formula 3.2. Okay, you need to understand and to refer this formula. This formula: A is the present value of ordinary annuity, R is the annuity payment, N is number of payment as usual, I is interest rate per period, and M number of compound as usual, and T is number of year. So in other words, the formula is like the same with the future value, but the difference is only I think the difference is only you can refer this power for the whole for the formula for future present value of money. Normally the power is negative, not positive. If the power is positive, you will get the bigger answer. Since the value of present value normally less than the value for the future. Be careful when you calculate this formula. So for this in order to find the present value of ordinary annuity, the following formula can be used. There is formula 3.3.2. Okay, for example, let's say for example, again we have 1,000. They have 1,000 ringgit uh, that deposit, and we are going to deposit 1,000 ringgit every month for 3 months. So we want to know the current value, the present value of the amount. Okay, that is equal to 1,000, 1 plus 1 plus 1 minus 1 plus 0.08 divided by m. Divided by m. M is number of compound. In this case, number of compound is since there is a year, number compound is 1. Number compound equal 1 to the power of, again, n equal to m equal to 1, t equal to 3. Now the power is negative 2. So divide by I is 0.08 divided by 1. You just finish the calculation. The answer is after the year 3, at the end of the period, uh, this amount of money will go to m 2,723.23. That the future value of present value of n. Okay. Another example. Okay, there is another example. 3.4. Example 3.4. Okay, assume that you are given two options. To receive, you are given the option to receive 10,000 compensation as follow. Let's say just for example, then how to relate. I would like to help how to I, I would like to relate the concept of present value of entity and the compensation. Let's say you are given the option to receive $10,000 compensation as follow. Compensation A is maybe package A is compensation A is 10,000 is paid at the beginning of 2031. You receive all the money at the end at the beginning of 2021. Okay, that's one option. The second option is 200,000 is paid at the end of year and the end of each year from 2021 to 2024. From 2021 to 2021 to 2025. 2,000 years for 5 years. The total is the same. The total is still 10,000. But the first one, they give you 10,000 ringgit at the one time. But plan B, conversion B, you are going to receive 10,000 ringgit. But now, in this, the amount of 10,000 ringgit is paid to you in 5 years at the end of 21, 22, 23, 24, and 25. 5 years. For each year, you will pay you will be paid 2,000 for each year. In total, you also receive the 10,000 ringgit in total. But the question is, what are your options? Which is the best? Whether option A or option B, uh, if you assume that the interest rate is 3% per annum compounded at the end of year. We need a method that we can use to help us to make a conclusion. Which one is better? Composition A or composition B? Okay, uh, how to uh, how to choose whether A or B. Okay, in this case, we can apply the concept of present value of anything. Uh, present value of anything. Why? Because this uh this concept, okay, this compensation 10,000 ringgit, you will especially for option B. For option A, no need to find their present value because the amount you receive at the beginning of term 2021, you receive the full amount of 10,000. But now we need to find the present value of the compensation B. Why? Because compensation B to the amount of the money, the amount of 10,000 ringgit is paid at the end of each year, which is 2,000 per year. So you will receive this amount, you receive this amount in future, not today. So we need to find the present value of this 10,000, where R, the amount of annuity that you will receive is 2,000. The interest rate 10% per annum compounded at the end of each year, m equal to 1. T, number of year equal 5. I 0.03, 0.03 divided by 1, 0.03, and n equal 5. Why n equal 5? Because the interest rate is compounded at the end of each year, which is at the end of year 1, year 2, year 3, and so forth. So the amount is fixed. But the amount 2,000 is fixed with this interest rate 3%. So to find this present value, we can use the formula 3.3. Formula 3.2. Formula 3.2 to find the present value of the conversion B. So R 2,000, interest rate 3%, 0.3 divided by 1, and n negative 5, which is 1 times 5 equal to 5. And then since this, we are using the we are using present value present value of annuity, then we need n equal to negative 5. So in total, the present value of P is 9,159 and 41 cents. That's the present value. In other words, the 10,000, the proposition B, they offer you 10,000 ringgit, but they will pay you in the future. The present value at that of the money that you will receive in the future is only 9,159 and 41 cents. Okay, that's why since the present value is low, is less than the amount of that you receive in the future, so we can conclude that uh, uh, the best option is to choose option A, because you will receive the money immediately. If you wait, if you receive the money, if you receive money, the compensation in future, the present value of the money will decrease or will low compared to the compensation A. Okay, therefore, in this case, we can apply concept of compensation. We can apply future present value of money in order to choose to make a decision which compensation is the best, especially for workers. Okay, that's the example for present value of energy. Okay, any questions so far? Now we have future value formula 3.1 and present value formula 3.2. Any question?
No question, doctor.
Okay, no question. I hope you can follow me. I think this topic is quite tough. But because this topic is related to the chapter 2. That simple interest and compound interest. Basically, we are still talking about the compound interest, but now we're talking in terms of annuity. Annuity include when we're talking about annuity, that's mean we refer to the situation where uh, there is a combination of future value is combination of the future value of money. Future value of present value of annuity is the combination of the present value of money. Okay, that's about uh, the future value and present value. Okay, the last part of this topic is about the application, how to apply in this concept in the concept of future value of entity and present value of entity in a loan, especially in Malaysia. This concept is applied in the housing loan. Uh, uh, for mention. Before I continue, I think before I proceed to topic 3.4, I think better we take a break for 50 minutes. Can we take a break for 50 minutes? Or you have any question?
No questions, doctor.
Okay, if so, we take a break for 50 minutes. We will continue at 4:25. It's okay? Okay, we take a break.